I want to talk today about a deficiency that I think deserves far more attention than it gets. Not because it's exotic, it isn't, it's genuinely common. But because it's frequently missed, it produces a very particular kind of exhaustion, and because if it's left unaddressed for long enough, some of the damage it causes may not be reversible. It's vitamin B12, and it connects directly to everything we talk about on this channel, in a more precise way than almost any other nutrient. Let me start with what makes B12 genuinely unusual. Most vitamins participate in a wide scatter of processes. B12 doesn't work like that. In the human body, B12 is required as a cofactor by exactly 2 enzymes. Just 2, in your entire biology. And I find that remarkable, because it means that when B12 runs short, you can trace the consequences with unusual precision. The first of those enzymes is called methionine synthase. It converts homocysteine into methionine, which feeds into DNA synthesis and into the methylation reactions your cells use constantly. The second enzyme is the one that matters most for this channel, and it's called methylmalonyl-CoA mutase. And here's the key detail. That enzyme is mitochondrial. It lives inside your cellular power plants. Its job is this. When your body breaks down certain fats and amino acids, it produces an intermediate compound. That mitochondrial enzyme takes that intermediate and converts it into succinyl-CoA, which then feeds directly into the citric acid cycle, also called the Krebs cycle. And the citric acid cycle is a central hub of cellular energy production. It's how the carbon from your food ultimately gets fed into the electron transport chain to make ATP. So follow the logic. Without enough B12, that mitochondrial enzyme can't do its job. The pathway stalls. The intermediate compound accumulates instead of being converted, and researchers describe these disrupted pathways as causing oxidative stress and impaired mitochondrial function. That is a direct, structural link between a common vitamin deficiency and your cellular energy production. Not a vague association. A missing part in a specific machine. And that explains something people who've experienced it describe consistently. B12 deficiency doesn't feel like ordinary tiredness. It's a heavy, sometimes bewildering exhaustion, often with mental fog, that doesn't lift with rest. Now let me get to the part that makes this genuinely urgent, rather than merely interesting. B12 is also essential for maintaining myelin, the protective insulating sheath around your nerves. When B12 stays low, that accumulating byproduct, along with elevated homocysteine, is implicated in damaging myelin. And the clinical consequences are serious. Deficiency can manifest as peripheral neuropathy, that's numbness, tingling, and pins and needles, particularly in the hands and feet. It can cause balance and coordination problems. It can cause cognitive impairment and memory difficulties. And in severe, prolonged cases, the literature is explicit that it can progress to irreversible neurodegeneration. That word, irreversible, is why I'm making this video. Caught reasonably early, B12 deficiency is very treatable, and people often recover well. Left for years, some of the nerve damage may become permanent. This is a genuine case where knowing about it, and acting, matters. So who's actually at risk? Let me give you the practical list. First, older adults. As you age, your stomach produces less acid, and you need stomach acid to release B12 from the protein in your food before you can absorb it. This is why B12 deficiency becomes markedly more common with age. There's even research suggesting older brains can show lower levels of the active forms of B12 despite normal blood levels, which points to a problem with getting it into cells, not just having it in circulation. Second, dietary intake. B12 is found essentially only in animal foods, meat, fish, eggs, and dairy. So if you eat little or no animal food, and you're not supplementing or eating fortified foods, you're at real risk. That's not an argument against any way of eating, it's just a fact to plan around. Third, and this is the one I most want people to hear, medications. Metformin, one of the most widely prescribed drugs in the world for type 2 diabetes, interferes with B12 absorption, and the risk climbs the longer you take it. So do proton pump inhibitors and other acid-reducing medications, because they lower the stomach acid you need. And research indicates that taking metformin together with these acid reducers can reduce B12 absorption dramatically, by as much as 65%. If you're on either of these long-term, this is genuinely worth raising with your doctor. So what should you actually do? Let me be clear and careful here. First, don't diagnose yourself from a list of symptoms. Fatigue, brain fog, and tingling have many possible causes, and guessing wrong wastes time you may not want to waste. Ask your doctor to test your B12 level. And if your levels come back borderline but your symptoms persist, it's worth asking about additional testing, because doctors can measure the byproducts that accumulate when that mitochondrial enzyme is starved, which can reveal a functional deficiency that a basic blood level misses. Second, and this is important, don't simply start taking high-dose supplements on your own. Now B12 is water-soluble, so excess is largely excreted, and it doesn't carry the accumulation danger that something like iron or vitamin D does. But here's the real problem with self-treating. If your deficiency is caused by an absorption problem, and it often is, swallowing a tablet may not correct it. Some people genuinely need injections. And by self-treating, you may partially mask the picture while never discovering the underlying cause, which might be something that needs attention in its own right. So where does a supplement like myelin fit into this? Nowhere, honestly, and I'll say so plainly. B12 is not an ingredient in myelin. And here's the deeper point. If your mitochondria are missing a cofactor they structurally require, no supporting nutrient substitutes for that missing part. You can't compensate for an absent component by supporting the machinery around it. If you're B12 deficient, B12 is the answer, and that's a conversation with your doctor. So here's the takeaway. Vitamin B12 is required by only 2 enzymes in your body, one of which sits inside your mitochondria feeding your energy cycle. Deficiency is common, especially with age and with certain medications. It causes a distinctive deep fatigue, and left too long it can cause lasting nerve damage. It's easy to test for and very treatable when caught. So if you're exhausted, ask. If you're exhausted, ask your doctor to check your B12. Check the link in the description below to learn more about supporting your cellular energy with myelin. And if you appreciate getting the honest version, including when the answer isn't anything I sell, hit subscribe. Every week we break down the real cellular science of healthy energy in plain language you can use. We post every morning. I want to be fully transparent with you. The link in the description below is an affiliate link. I might earn a small commission at no extra cost to you. I only share what I genuinely think is helpful. This video is for educational purposes only and is not intended as medical advice. Always consult a qualified healthcare professional before making changes to your diet or lifestyle.